So let's solve a right triangle. We're given a certain amount of information. We're given an angle, and we're given a side. So it's a right triangle. Here's our right angle. And remember that the diagram does not have to be representative of the actual sides or the way the triangle looks. It's just nice to have a triangle there to visualize it. I don't really know how this one's going to turn out. So I have an angle A, which is 39 degrees. And I have a side C, which is radical 17 in length. Those are both filled in over here in my answer key. Well, I know that C is my right angle, so that's 90 degrees. And I know that the other two angles together have to make 90 degrees. So that means B is 51 degrees. So already I've got 4/6. I've got 2/3 of my thing solved. That's pretty nice. So we may as well write in our 51 degrees. And so I need to find B and A. And I can use any number of trigonometric functions to do that. So I think I'm going to start by trying to find side B. And side B is opposite angle B. You'll notice that the sides and the angles are lettered the same when they're opposite one another. So I could do sine 51 degrees is equal to opposite, which is B, over hypotenuse, which is C, which is radical 17. So let's just write something else on here so that we have it. I always write at the top of my paper, so toa. So I remember the relationships to find sine, cosine, and tangent. So sine 51 degrees is my opposite, which is B, over my hypotenuse, which is radical 17. So doing a little bit of algebra, that means B is equal to radical 17 times sine 51 degrees. And usually we leave out the little dot. You can put just radical 17 sine 51 degrees. Whoops, wrong color. Radical 17 sine 51, just like when you're doing AB, the dot is assumed. It's the same thing. It's a product. It's assumed here. So let's find out what that's equal to. Here's our calculator. I'm going to go square root of 17, and I'm going to multiply that by sine 51, and hope that I'm in degrees. I'll look in a minute. And I enter, and I find that it's 2.76. So side B should be 2.76. Let's write that in here. 2.76. Let's just double check, make sure I'm in. Mistake. I'm in radians. Bad, Mr. Jenkins. Let's go to degrees. Enter that. Oh, this is good. See, now you see what kind of mistake you can make. I'm going to go back up here, and I'm going to go radical 17 sine 51 and hit enter again. Now I get 3.20. That's a better answer. So we'll erase this. We'll erase this. And we'll say 3.20 and 3.20. All right, so that takes care of B. And for A, I think I'm going to do A using, I'm going to say that sine 39 degrees is equal to A divided by radical 17. So, again, radical 17 sine 39 degrees should equal side A. So we'll go second, radical 17 sine 39, enter, 2.59. 2.59. 2.59. And that is the correct answer. So I did my work over here, but I put my answer in the answer key so that it's easier to read. And, just for the heck of it, why don't we check it using the Pythagorean theorem? So let's pull up our calculator again, and let's go a squared plus b squared equals c squared. So 3.2 squared plus 2.59 squared. I hit enter. Almost 17, right? Which would be the square root of 17 squared. So I would say that is a correct answer. If I had left it in the radians and I checked it like that, it would have been a wrong answer. Just to be clear here, I didn't have to use sine. I could have said that, for example, cosine 51 degrees would have been equal to A over radical 17. Or I could have said cosine 39 degrees was equal to B over radical 17. So there's a lot of different ways I could have done that. But this was the way that I chose, and it worked out just fine. So you're using your sine and cosine and sometimes your tangent functions to solve right triangles.